Hello and welcome. In today's lecture, we will see how to solve the exclusive OR problem using a multi-layer perceptron. So let's start. This is basically the truth table of the exclusive OR. Exclusive OR is a binary logic gate, or it is a Boolean logic gate function that outputs a value of 1 when only one of its input is 1. Otherwise, it outputs a value of 0. This is the truth table of the exclusive OR that works on two inputs x1 and x2, and y is the output. When both the inputs, the x1 and x2, are having a value of 0, then this function, the exclusive OR, outputs a value of 0. And whenever both of these inputs, the x1 and x2, are 1, then it also outputs a value of 0. But whenever only one of the input, either the x1 or the x2, is 1, then this function outputs a value of 1. In today's lecture, we will see how to simulate this exclusive OR through a multi-layer perceptron. If you remembered, we discussed that a multi-layer perceptron is a neural network that is made up from more than just the input and the output layer. Because in a multi-layer perceptron, there are one or many hidden layers. So let's see. For this, the multi-layer perceptron could look something like this, where you will have one input layer, okay, where there will be the two inputs will be processed, the x1 and x2. This is your input layer, and there will be one hidden layer where there will be two neurons, the z1 and z2. This is the hidden layer, and there will be one output layer. Okay, this is the output layer, and in the output layer there is only one neuron y. And from the input layer, the inputs will be passed to the neurons in the hidden layer, okay, and from the hidden layer the neurons will pass signal to the neuron in the output layer, and then finally you will get a value at the output layer, either 0 or 1. Okay, so this is the setting. This is the multi-layer perceptron that could be used to solve the exclusive OR problem. And with these connection there will be associated weights as 2 minus 1 minus 1 2 2 2. This means that the weight associated with this connection that connects the x1 with z1 is 2, and the weight associated with the connection going from x2 to z1 is the minus 1. The weight associated with the connection going from x1 to the z2 is minus 1. The weight associated with the connection going from x2 to z2 is 2. The weight associated with the connection going from z1 to y is 2, and the weight associated with the connection going from the z2 to y is 2. Okay, so these are the weights, and there is also thresholds and biases. With these weights from the input layer to the hidden layer, the associated bias is minus 1 and the threshold is 1. And with this, from the hidden layer to the output layer, the bias is having a value of 0 and the threshold theta is having a value of 1. So now let's see how the weighted summation at these nodes will be calculated, because these are the input nodes that passes the inputs values to the hidden layer. So the weighted summation will be calculated at this node, then a thresholding will be applied. function will be applied, and then here the weighted summation will be calculated, and then again the thresholding function will be applied, and then their outputs will be passed to this node, to the y. Here again the weighted summation will be first calculated, and then the thresholding function will be applied, and then finally the output will be generated here. So this is the setting. So in this case at the z1, okay, where the bias is having a value is -1, the theta, the threshold is 1. The weighted summation will be calculated as x0, which is the bias, plus 2 of x1, where 2 is this weight and the x1 is the input coming from the node x1, plus -1 is the weight, this one weight that is coming with a connection coming from the node x2 to z1, and x2 is that one node from which the input will be coming from the x2. So in simplified term, it will become as x0 plus 2 of x1 minus x2. So the weighted summation at the node z1 will be calculated as by putting the values of x0, which is the -1, it is a bias, plus 2 of x1, which will be the value at that time stored by the variable by the x1, minus x2. Again, it will be again another input, because we are simulating the exclusive OR for two inputs. So the first input is the x1 and the second one is the x2. And similarly, the weighted summation at the node z2, which is a neuron in the hidden layer, which is the second neuron in the hidden layer, will be calculated as x0, which is the bias, plus -1 this weight multiplied with the x1, the input coming from the node x1, plus 2 of x2, 2 is this one weight, multiplied by x2, which is the input coming from the node x2. After simplifying, it will become as x0 minus x1 plus 2 of x2. Okay, so with this equation we will be calculating the weighted summation at the neuron z2, okay, where we will put simply the values of x1, x2, where x1 and x2 these are the first and second inputs, and the x0 is the bias, which is constant to -1. And then at the output layer, at the node y, which at the neuron y, which is the only neuron in the output layer, the weighted summation will be calculated as z0, which is the bias, which is having a value of 0, plus 2 of z1. 2 is the weight associated with the connection coming from the node, from the neuron z1 in the hidden layer to the neuron y in the output layer, plus 2 of z2. Again, 2 is this one weight, and z2 is the neuron, the second neuron in the hidden layer. After simplifying it, is the z0, the bias is having a value of 0. So when its value is put is 0 plus 2 of z1 plus 2 of z2, then it becomes as 2 of z1 plus 2 of z2. So with this equation, the weighted summation at the output layer node y will be calculated, and then again to this a thresholding function will be applied, and finally the output will be generated from this multi-layer perceptron. Okay, now let's simulate it for one case. Now let's first of all pick this one case where we have both the inputs, the x1 is having a value is 0 and the x2 is having a value is 0, and we expect our output value to be 0 also. So this is the case one where the x1 is having a value is 0 and the x2 is having a value is 0. So after putting these values at the z1 for calculating the weighted summation at the node z1, we will get as -1 plus 2 of x1, which is 0, minus x2, which is 0. x0 is here the bias, which is equal to -1. So after simplifying it, it becomes as -1 plus 2 multiplied by 0, it is 0 minus 0. These will be cancelled, and as a result we will get the output value at the z1 is -1. But remember that the threshold here it is 1. So the weighted summation at the node z1, if it is -1 and it is less than theta, The threshold theta is 1. So in this case, this neuron Z will output a value is 0 here. That will be then passed here to the Y. And similarly at the Z2, while calculating the weighted summation, when we will put the values of x1 and x2 and x0, x0 is the bias minus 1, put is minus 1 plus minus x1, it is 0, 0 plus 2 of x2, x2 is also 0. So in this case again minus 1 minus 0 plus 2 of 0, it is minus 1 minus 0 plus 0 because 2 of 0 is 0. So this will be cancelled. Again the at the node Z2, the calculated weighted summation is equal to minus 1 and it is less than threshold theta. So thus it will also outputs a value of 0 here. Okay. So now at the output node, at the in the output layer in the neuron Y, the weighted summation will be calculated as 2 of multiplied by 0, which is this the Z1, the input coming from the Z1, 0 plus 2 of 0, and it will be 0 plus 0, it is 0, and the threshold is 1. So this calculated weighted sum at the node Y is also less than threshold. Therefore, it will also output a value is 0. And as a result, we will get the output value is 0, which is 0 in this case. Okay. So this is the case 1 when we will be having both the inputs, the x1 and x2 will having a value is 0. Now let's see the second case where we will be having the x1 having a value is 0 and the x2 is having a value is 1, and we expect our output value to be 1. So in this case x1 is having value is 0 and the x2 is having a value is 1. So first of all, the weighted summation will be calculated at the node Z1 is, and we will put the values 2 multiplied by 0, it is 0. Okay. And minus 1, again minus 1 with this one, it will be minus 1. And again the bias it is minus 1, and it will be cancelled. So we will get a value is 0 and the threshold theta is 1. So again the calculated weighted sum is less than the threshold, therefore this node will output a value is 0. Okay. And similarly at the node Z2, the weighted summation will be calculated as x0 minus x1 plus 2 of x2, where x0 is the constant having a value is minus 1, which is the bias, and x1 is having a value is 0, and it will be substituted here is 0 plus 2 of x2, which is the second input having a value is 1. So in this case, it will be minus 1 minus 0 plus 2. So now it will be Z2 will be equal to 1. In this case, now the weighted summation at the neuron Z2 it is 1 and it is equal to threshold theta. So in this case, this neuron will be activated and it will pass a value is 1. Next, at the neuron Y, which is the neuron at the output layer, a weighted summation will be calculated as 2 multiplied by 0, which is the input coming from the neuron Z1 plus 2 of Z2, which is the input coming from the neuron Z2. The Z1 is passing here a value is 0 and the Z2 is passing here a value is 1. So after substituting these values, it will become 0 plus 2 and the weighted summation at the neuron Y, it is now 2 and it is greater than the threshold, which is 1. In this case, this neuron will be activated, which is the neuron at the output layer, and a value 1 will be generated. And we expect here 1, and it is expected 1. So this is the one case. And similarly, you can even also simulate this for the third case where we have the first input, the x1 having a value is 1 and the x2, the second input having a value is 0, and it is expected that the neuron Y at the output layer will give us will give us a value of 1. So you can simulate it through this. I have also did it, so I can't waste further time on this. Okay, this is similar to the previous case. Okay, and now let's see the fourth one case where we have both the inputs, the x1 and the x2 is having a value as 1, and at the output it is expected that the output value will be 0. So in this case, when we will substitute these values as 1 and 1 for calculating the weighted summation at the neuron Z1, after substituting the values x1 as a bias minus having a value is -1 plus 2 of x1, which is the having value is 1, minus x2 is having a value is 1. So in this case, it will become -1 plus 2 minus 1. It will be cancelled with one another. So we will get the output value is 0. And the weighted summation at the neuron Z1, it is now 0. And the threshold is 1. So it is again less than the threshold. Therefore, this neuron, this Z1, will pass a value is 0. In this case, it will output a value is 0. And similarly, at the neuron Z2, which is the second neuron in the hidden layer, the weighted summation is calculated as x0 minus x1 plus 2 of x2, where x0 is the bias, x1 is the first input, plus 2 of x2, x2 is the second input, 2 is the weight, so on and so forth. So after substituting these values, -1, -1 is the bias, minus 1 x1 is having a value is 1, plus 2 of x2, x2 is having a value is 1 also. So in this case again -1 plus 2, it will be cancelled with one another and we'll get a value is 0. So in this case also at the neuron Z2, the weighted summation is equal to 0, which is again less than the threshold, which is theta 1, having a value is 1. So in this case, this neuron will also output a value is 0. And further that when these generated output values by these neurons, the Z1 and Z2 will be passed, it will be further multiplied with the weights associated with these, that is going to the neuron Y. And the weighted summation at the neuron Y is calculated as 2 of Z1 plus 2 of Z2, where the Z1 has produced an output value is 0 and same Z2 also. So after substituting these values and multiplying with the weights, it is 0 plus 0, it is 0, and the threshold here in this case it is 1, and the calculated weighted sum at the neuron Y again is less than the threshold theta, which is 1. So in this case, this neuron, which is the neuron in the output layer, which is Y, it will again output a value 0, which is expected here also. So this was just one solution for solving the exclusive OR problem through a multi-layer perceptron. Okay, there are other solutions also possible. You can also even also apply the theorem of multi-layer perceptron, where you can develop a multi-layer perceptron for two inputs, as having in this case we have two inputs. So you can develop a multi-layer perceptron with one hidden layer. In that hidden layer you will include 2 raised to the power 2, because 2, the number of inputs are 2, 4 neurons. You will include 4 neurons in the hidden layer plus 1 neuron in the output layer. You can even also solve this problem with that. But in this case, we have solved the same problem with less neurons in the hidden layer, which we have discussed in the lecture in the theorem of multi-layer perceptron, that it is possible that we can find a solution, that we can find a multi-layer perceptron solution and with less than 2 raised to the power n neurons. So this was all about today's lecture. I hope you will have enjoyed today's lecture. If you have liked today's lecture, please like the lecture at the YouTube, subscribe this channel and share it with your friends. Thank you so much. See you in the next lecture.